So you have your piece of paper. I want it landscape. See how mine's landscape? Okay. First thing I want to do is take the top and fold it down about an inch. Thank you. Okay. Take the top and fold it down about an inch. Now, I'm not really great at drawing straight lines, so a little hint to make sure, because what we're going to do, I want this darkened right here. Little hint to just leave it folded, not all the way, but enough where you can get your pencil in there and just go right along the edge. And then look how beautiful that is, except for the end. Sorry. Does that make sense? Everybody okay so far? Now, I'm going to take the right-hand side of the paper, and I'm going to fold it over, but not halfway. I need more room in one section than the other section. So about that much. You see that? I'm pulling only the right side up. Only the right side. Pardon? That's great. Yep, that's great. Now when I draw this line, I only want it to go from the line I drew before to the bottom. Does that make sense? We good? Okay. So this is going to be our map today. Okay, our thinking map. It's a way to organize our thoughts. Okay, and we're going to use this today to organize some numbers that we talk about in this class. Okay. The title of this page is Real Numbers. So I have that up at the top. Now you know that there's a symbol that we use to represent real numbers, right? What is that symbol? Yeah, the funny R, right? Some people call it a double R. Let's go ahead and have that up there as well. Now, I'm going to zoom in just a little bit on this. Whoa, not out, in. Just on this section right here. Okay? We're going to start in the middle of this section. These are called natural numbers. Sometimes they're called counting numbers because they're typically the numbers you first learn how to count with. What are those numbers? 1, 2, 3, and so on, right? 1, 2, and 3, and so on. Just like real numbers, though, has this fancy R that we use to represent it, natural numbers also has a fancy letter. And if I can draw it, it looks like that. It's an N, right? R has a double bar right here. N has a double bar across the middle. So are these the only kind of numbers we ever talk about? No. We have some more kinds of numbers. These are called whole numbers. Guess what also has a fancy letter that represents it? Guess what it is? A W. It has a double bar right here. Oh, I didn't do very good at that. I'm sorry. It's wonky. Now, are all of the natural numbers also whole numbers? Yeah, you can tell that by how we drew it, right? The whole set of natural numbers is inside of the set of whole numbers. Okay? So what do we add to these natural numbers to make whole numbers? I'll give you a hint. There's only one. 0. 0 is not a natural number, but it is a whole number. Okay? Think about it counting. If you're counting something, you don't typically say 0, 1, 2, 3, do you? Okay, you start at 1. Whole numbers include a 0. So if I say to you, classify the number 3. It's a natural number and a whole number. You okay with that? Classify the number 0. It's a whole number. It's not a natural number, is it? Okay? So what are we missing? Negatives. Okay, so let's talk about negatives next, because they actually happen next. Do you know what those are called? Integers. There's a fancy letter that goes with that. Guess what it is? Nope, good try. It's a Z. Why is it a Z? The best answer that I have is I have no idea. Maybe integers in some other language starts with a Z. I really have no idea. I just made that up. Okay. Why didn't we just use I? I already has 2 lines? How do you draw your eyes? Okay. Why else might we not use an I? Because it might look like an 11, or it might just look like a 1. Okay? So they chose another letter to represent that. Okay? So integers, what are we missing? What do integers entail besides natural and whole? Negatives, right? So -3, -2, -1, -7, -12. All the negatives numbers, right? Sometimes people will say negative whole numbers, but that's not really quite right. Okay? Those are actually integers. Okay? So what's left in this whole side right here are rational numbers. Guess what letter? Nope, good try. Sorry. I have to concentrate when I do this one. And I still did a bad job. It's a Q. I did better last period, look. See? Q. It's a Q for rational. It's like Q, it means like crazy. I know crazy doesn't start with Q, I'm sorry. Okay. So what are we missing? Decimals and fractions, right? So give me some examples. 1/2, 0.4. Those are the only examples you know? 0.753140, is that what you said? Okay. What'd you say? 0.0125. Okay. Can you write pi as a fraction? So if rational numbers are numbers that can be written as a fraction, what do you think might go here? Numbers that can't be written as a fraction. And what do you think they're called? Guess what letter we use for that? Nope. Good guess. We don't have one. At least not that we use at our level. Okay, there might be one. I don't care. What are some examples of irrational numbers? We've talked actually about 2 lately. 0.3 repeating. Think about what you're saying. These are numbers that can be written as a fraction. These are numbers that can't be written. Can we write 0.3 repeating as a fraction? That's 1/3, right? So that is a rational number. Pi is one of them. The other one we talked about yesterday. Very good. Okay. Now, are those the only 2 irrational numbers? No, but that's how we're going to leave our map, our thinking map right now. Okay. Any questions about this so far? So you guys might want to refer back to this today as we go through the examples and as you go through your homework tonight. Okay? So take some paper out for some notes. This is also going to go in the notes section of your notebook. Okay? So if you want to use my punch hole here in a little while and punch some holes, put it in your notes section, that's fine. But I'm going to keep mine right here to the side, just right over here, so I can refer back to it in a little while if we need to. Okay? So first things first. What are we talking about today, by the way? So we've been talking about domains since the beginning, haven't we? Since the very first day of school, we talked about domains. The domains that we've talked about so far are domains, God bless you, domains that are related to parent functions, right? So this is an x and a y coordinate. But everything we do is not always on an x and y coordinate plane. Sometimes it's just a number line, right? I need to make sure you can write a domain from just a straight number line. Okay? You know how to write things in inequality notation. You know how to write domains in interval notation. Can you go back and forth? Can you? Okay, so let's give it a try first. I'm going to give you a number line. Let's see, what do I want to use? I want to know if you know how to write that domain. I need you to be able to write it in inequality notation and in interval notation. We always start low and go higher. I see what you're trying to do. I promise I do. But you had it right the first time. Okay? It's not wrong the way you're saying it. It just might be confusing. Fair? X greater than or equal to negative 3. This is what you're trying to do right here, right? You want to start at negative 3 and go to infinity. But negative 3 is going to have a bracket, good, and the infinity will have a parentheses. You okay with that? So I have to teach you one more way to write domain. This one's called inequality notation. This one's interval notation. You need to know set builder notation. Except you already know how to do it, mostly. For real. Okay? Here's what set builder notation looks like for this particular problem right here. Do you see why I said you mostly know how to do it already? Super closely related to inequality notation, right? So here's what I need you to know. By using set builder notation, you're telling your reader, we're using an X. This vertical line, it's a vertical line, it's not a 1, it's just a vertical line. We're saying X such that X is greater than or equal to negative 3. So the only difference between inequality notation and set builder notation is we use these pretty braces and we tell our reader we're talking about the variable X. And then we use a vertical line, means X such that X is greater than or equal to negative 3. Done. Okay? So what I need you to be able to do today is go back and forth between these three. If I give you interval, I need you to be able to give me inequality. If I give you set builder, you need to be able to give me interval. And also, if I give you a number line, you need to be able to give me any of these three. Can you do that? Okay? So what about if it says X is less than 2? If that's inequality notation, what does interval notation look like? Not bracket? Negative infinity. So 2. Parenthesis or bracket? Parenthesis. What's the set builder notation look like for this? Braces, my vertical line, X is less than 2. Can you tell me what the number line looks like? Tell me what to draw. Ooh, an open circlet too. I love that you remember things. And to the left, right? I mean left. I shouldn't say left, right. I should say to the left, correct? Now, some of you, especially if you're a visual learner, and I give you this, in order to give me both of these other two, you might want to draw your number line first, because you can see that better. Okay? These two make more sense sometimes. Well, not this so much, but interval notation might make more sense if you had a number line. I don't know. I don't know what kind of learners you guys are yet. I'm a visual learner. If I'm given an inequality notation, I'm almost always going to draw this or at least see it in my head before I write my interval notation. Okay? So, can I try to trick you? Okay. There's interval notation. Can you tell me inequality, set builder, and draw the number line? Okay, what do you want to do first? Number line? Okay. What's the number line look like? What's it look like? Closed circle at 4. Ooh, open circle at 9. Okay. And then in between it, right? And I'm going to have to work harder to try to trick you guys, huh? Okay, what about inequality or set builder? Which one do you want to do? Inequality, okay. What's that look like? Wow. Very good. And set builder? Braces. Such that. Then this, just this, right? 4 is less than or equal to x is less than 9. Huh? You guys are so smart. Let me take that back. You remember what you were taught very well. How about that? Plus, you're probably smart too. Okay, so that's the first half of the lesson. You okay with that? Then I just need you to be able to write some sets for me. Set builder notation looks like this, which means we're using the braces. Okay? I need you to be able to write things like all the whole numbers less than 4. What would it look like if I want you to write all the whole numbers less than 4? Well, if I'm asking for the set of whole numbers less than 4, I'm going to use a brace. What's the lowest whole number less than 4? 0. Then what? 1. Then what? Then what? Then what? Do we have 4 or no? Why? Oh, it's not less than 4. 4 is not less than 4, is it? So then I close my braces and then I'm done. Write me the set of integers greater than 3. What's the lowest integer greater than 3? I want integers greater than 3, so it would be what? 4, 5, 6, 7, 8, Anybody see a problem? How long am I gonna when am I gonna finish my homework if I'm writing all the integers greater than 3? Never. Never ever. Yes, we can. 5. Okay, I want 5. If you're going to use the ellipses to signify that it's continuing, I want at least 5 values so that I can make sure you understand what you've written. Okay? What about integers less than or equal to 2? What's the lowest integer less than or equal to 2? We need it less than or equal to 2. So if we're looking at a number line, what's the lowest integer less than or equal to 2? All of it, right? All the way. So how do we signify that? The dots. They're just on this side because it's going to the left, right? Then what? If I need 5, where do you want to start? -2? -1? 0? 1? 2. Brace. I agree with you that -3 is an integer less than or equal to 2. And would it be wrong if you had it on the list? No, because all I asked for was at least 5, right? I'm not saying exactly 5. I'm saying at least 5. Okay? Does that make sense? So if I give you sentences like this with words like whole numbers and integers, if you need to refer back to this, you can, right? You might not. You might already understand this and know this, and that's great, okay? But can you give me lists of stuff like that? Can you go in between all of these things right here? All right, you ready for your homework then? Peace. Oh, wait, I do have to show you one more thing. One more thing, only because it's funny, okay? They were asking earlier, how do you remember which one to use with which? Okay? So what I said, not realizing it, is if you use a less than or greater than sign on a graph, a number line, what kind of symbol is going to be there? An open circle, right? And you're going to need parentheses. Just because this is here doesn't mean you're always using this one, right? It depends on what you're doing. But if you use less than or equal, greater than or equal, that's a closed circle, and we're using brackets. And to me, those look like monsters. So if you want that, that's a helpful tool if you need that. Okay? Now, peace.